Okay, so the double slit experiment was performed in 1927, and it was responsible for quantum mechanics. And it went a little something like this. You have a room. In the middle of the room is a panel, let's say a piece of cardboard with two slits. Now you take a tiny cannon capable of firing little particles one at a time. Think of a paintball gun and paintballs. Now you fire thousands of these paintballs at the piece of cardboard with two slits. And what you should end up with on the back wall of the room is two stripes where the paint got through. And that's how particles behave. And that result is not surprising. It makes sense. Now let's take a wave, say a bucket of water, and we do the same thing. We pour that bucket of water at the cardboard with two slits, and what we should end up with is what scientists call an interference pattern. So what is an interference pattern? It's just a fancy way of saying that we would see the crests of the waves that hit the wall show up as stripes, and the dips in the waves wouldn't show up. So you'd end up with this series of stripes that looks something like this. This is an interference pattern. And again, that result is not surprising. It makes sense. Now let's take the basic unit of light, photons, these tiny little particles of light, and fire thousands of them, one by one, at the piece of cardboard with two slits. Well, we'd be here all day, so let's go to the bar, we'll grab a drink, and we'll come back in a few hours and we'll see what's happened. What do we find when we return? An interference pattern. Somehow, these photons that we fired one by one have behaved like water, like waves. Scientists were baffled. So they ran the experiment again and they said, okay, no going out for drinks this time. We are going to put little sensors on each one of these slits, and the photons are going to go through one of the two slits, and we are going to know about it, run the experiment again. And now that the photons were being observed, they changed their behavior. They started behaving like particles and showed up as two stripes on the back wall. Mind blown. So, being scientists, they run the experiment again and again with detectors, without detectors, and when the photons aren't observed, they behave like waves. And when the photons are observed, they behave like particles. The act of observing literally changes the way the world works on the most fundamental level. So why is this happening? What is going on? And the answer is still up for debate. It birthed the entire field of quantum mechanics. But a popular theory is that photons move in a probability wave, meaning they express their potential when they aren't observed. The interference pattern is an expression of potential. Here are all the places we could be. And it's not until they're observed that they're forced to choose a definite path and thus behave like particles. Now, all this scientific blathering is not too far removed from us. We are shot into existence with unlimited potential, and we fly through time towards a wall called death. And the two slits could be any metaphorical fork in the road whereby being observed by oneself or someone else, we have to choose a definite path. But more on that later. So, now that we know all about waves and lights and particles and double slit experiment and all that jazz, let's talk about fractals. Fractals are everywhere, man. It's like the universe figured out the best way to occupy space. So you see it in nature all the time. And a quality of fractals is something called self-similarity. And that's just the idea that things look the same when you scale up or scale down. Like a twig looks like a branch, looks like a tree. Ferns are actually a great example. So between two ferns, more like between two self-replicating infinities. Am I right? So I bring up fractals and self-similarity because I'm curious of our position. We exist in this matrix by which everything operates too. And we are constantly both the observer and the observed. So when we are shot out of the cannon, when does our probability wave get disrupted by being observed? When does our expression of potential become a definite path? And how do we affect that path with what we choose to observe? Is our constant overlap with one another as both the observer and the observed creating an interference pattern of its own? Are we particles or are we waves? Thank you.